a statement term. P implies Q. Q implies P. Not P implies not Q. And then lastly, not Q implies not P. Yeah, and that's why I wanted to switch back to the little squiggly as opposed to that little bar line. Remember, they mean the same thing. I have a bad habit of switching between the two, and that way you see them both just in case. So what happened yesterday was that most of the things that we did were non-math related. We found out that the first statement was true, the next one was false, this one was false, and then the last one was true. And that was pretty normal for what we were doing yesterday. Now, today what's going to happen is that we're going to wind up with sometimes these statements could all be false, sometimes these statements could all be true. What we worry about, though, is this term called biconditional. When we're worrying about this thing called biconditional, it basically means that if these two guys are both true, if both of those are true, it means it's a biconditional statement. What that means is you can say it truthfully forward and backward. You see that a lot with definitions, and that's why we talk about it in terms of definitions. A biconditional statement is basically saying that whatever conditional statement you come up with, if the conditional statement is true and its converse is true, it could be called what's a biconditional. Really, really simple, easy way, simple one to look at is if I use a definition, a statement, acute angles measure less than 90. You guys agree with me on that one? You okay with that one? So if I say, let me put this on 21. Acute angles measure less than 90. Is that in if-then statement? No. What would you do to change that to an if-then statement? Yeah, the only one you forgot was then. Exactly. Perfect. So I don't know if you guys all heard her. What she said was, for your conditional, if an angle is acute, gentlemen, enough. Okay? Then it measures less than 90 degrees. Okay? Is that true or false? That's true. Okay? That's the definition of an acute angle. All right? This is a true statement. Now, if I do the converse of that, we basically say that in reverse. So if I say that statement in reverse, instead of if an angle is acute, then it measures less than 90. If an angle measures less than 90, then it is acute. Okay? Is that true? Yeah, that's also true. If an angle measures less than 90, then it is acute. That is true. So what happens here is that since both of these guys are true, since they're true going forward and backwards, that means both conditions are true. So the word biconditional comes up with two conditions. Forward and backwards work. Yeah?
So I mean, if both of these true, then we need the other two.
So if an angle is not acute, then it is not less than 90. Well, hold on. If an angle is not acute, then it is not less than 90. Is that true? If an angle is not less than 90, then it is not acute. In this case, you have all of them true. Right? But we only worry about once we get the first two, that means the other two have to be right. That's a great pickup. So what we do here is we wind up being able to rewrite this. You can rewrite this as what's called a biconditional statement. And in a biconditional statement, it uses the term if and only if. An angle is acute if and only if it measures less than 90. If and only if. If. IFF. This stands for if and only if. An angle is acute if and only if it measures less than 90 degrees. An angle measures less than 90 degrees if and only if it is acute. It means the same thing going forwards and backwards. That's where this comes from. Okay? The term if and only if is used generally with things that are definitions. We just defined an acute angle as an angle that measures less than 90. We reworded it so that way we could use the term if and only if. Okay? So really the stuff that's different from yesterday, if anything, your first two are true. Okay? Your first two wind up being true. When those two are both true, you can rewrite it as what's called biconditional. You can put the word if and only if. Not terrible? Usually isn't. And it stems from definitions. You're not going to usually see an if and only if, yesterday say if you were a teenager then you were 15. Well, it's not necessarily true. So things like that you don't normally see. You'll see it with things that have definitions. Let's try that. Oops. Two angles are complementary if their sum is 90. What's the word sum mean again? Yeah, they add. Remember how we define complementary angles? Complementary angles always add up to equal what? Complementary. 90. We used this as a definition before. Well, what we do is, first thing we always do is when you're given a statement like this, two angles are complementary if their sums are 90, is that we're automatically going to rewrite that as an if-then statement or measure conditional. Two angles are complementary if their sum is 90. So the first thing I want to do is change that so that it's a P implies Q. If two angles are complementary, then their sum is 90. Does that make sense? Okay. If two angles are complementary, start with that. If two angles are complementary, then their sum equals 90. By all means, if you want to use symbols like we've been using, or if you want to write it out with words, it's fine. My handwriting is awful. My spelling is pretty bad. I'm going to use as many abbreviations. I'm going to use as many abbreviations and symbols as I possibly can, just so it looks a little bit clearer. I mean, it still looks pretty bad, but yeah. All right? Now, how would you say that in reverse? If what sum? Sum of what? Sum of the, yeah. See how you want to make sure just the sum is 90. Well, 45 and 45 are 90, right? Yeah, you just got to throw that in there, okay? Just want to make sure you heard yourself say that. If the sum, bless you, if the sum of two angles is 90 degrees. Or if two angles have a sum of 90 degrees, either way it means the same thing. Then they are complementary. Okay? Then they are complementary angles. Is that true? Oh, I forgot to ask, was the first one true? Since they're both true, that means that this can be rewritten as what we call biconditional. So we can rewrite that original statement as an if. Okay? So what do you think it would look like?
Two angles. If two angles are non-complementary, if it only is something.
Perfect. That's all it is. It is basically what we started with. Two angles, so biconditional. Two angles are complementary if and only if their sum equals 90 degrees. Two angles are complementary if and only if, or you want to say if, that's fine as well. Their sum equals 90 degrees. And that's a straight definition. If two angles have a sum of 90 degrees, then they are complementary. Two angles are complementary, and then their sum is 90 degrees. It means the same thing forward and backwards. Now, we don't worry about doing inverse and contrapositive with these things. It just gets too wordy. If two angles are not complementary, if their sum is not 90, I mean, it's just too many words. That's why we usually just worry about the first two. And I don't think I've ever seen an if and only if statement with negation. It just doesn't make any sense. Woo-hoo. Oops, sorry, I missed one. Okay. Do you guys know what I mean? What a polygon is? What's a polygon? Yes, ma'am. Angle? What do you? Shapes, yeah. Shapes with more than two sides, yeah. No, that's fine. It's okay. You caught yourself. So a shape with more than two sides. So you start when you have three sides. What's that called? What's four-sided called? No. Quadrilateral. Very good. Quadrilateral. What about five-sided? Hexagon. And then so on and so on and so on. Okay. So we're talking about six. You're just a step ahead. So when you're dealing with polygons, you have things called equilateral. Equilateral stems from the actual word, the Latin word side, equal sides. So equilateral just means that all the sides are equal. You guys have done that with what we call an equilateral triangle. An equilateral triangle has all three sides equal. All three sides are the same, all three angles are the same. A stop sign. How many sides does a stop sign have? 8. It's called an octagon.
So, what if it was a hexagon, right? But not all sides are equal.
It's still an hexagon. Correct. Now, come back to this in 1 second. There's two types of polygons. You have 1, 2, 3, 4, 5, 6. There's 6 sides, right? It's a hexagon. This is a convex polygon. No, it's just regular. It's just normal run-of-the-mill polygon. This would be convex. A concave polygon still has 6 sides, but one side moved inward. It caved in. We don't normally ever deal with concave. We deal with convex. We can still work with this, but there's really no math thing you can do with it. the mathing that we'll be able to do when you get to what we call a regular one, we know that all those sides are the same, which means that all of these sides would be the same. We actually made this picture before with the circle. I don't know if you guys, we did that when you walked around the circle, we marked it all off. We found that all of these were the same because all of these were the same. You can do so much stuff with those things, but that's a good question. But anyway, so an equilateral polygon, all sides are congruent. Take a minute, come up with the P to Q, come up with the Q to P. If they are both true, then give me an if. Okay? If they're both true, give me an if.
No.
Hey. Seriously.
I wasn't saying it.
Come on.
I wasn't.
I just asked you to do one problem.
I didn't say it. I literally said
Because this is, we're using real time. All right. So P to Q, what do you guys have? What do you have? P to Q. If a polygon is equilateral, then all sides are congruent. You guys agree? I also heard people or saw people writing, if you have an equilateral polygon, then all sides are congruent. It means the exact same thing. Okay? It means the exact same thing when you're writing those things out. The vocab, as you know, as you're writing sentences, the structure of the sentence can still mean the same thing if you put words in different order. And that's okay. And that's what's weird for a lot of students to come into the realization that you can say things a little bit differently, but still be correct. Okay? So we have, if the polygon is equilateral, then all sides If all sides are congruent, then you have an equilateral. Right. A polygon that's equilateral or equilateral polygon. Exactly. So, once again, how you word it is very winds up being very specific to how you think. Okay? And it's okay that if one person thinks of it one way versus the way that you do. Because you can still be correct as you go through all of it. And that's fine. Okay? So now to me, as an if and only if, I would say polygon is equilateral if all the sides are congruent. See how that works? Not terrible, is it? Okay. Now, the homework stuff that I want you guys to do, I want to explain some of the instructions that I put on the calendar. I put these on the calendar as far as what I want you guys to do within these. So, let me re-explain this to you guys while you're all here. Now, on numbers 7 and 9, you are given, please, heads up. You are given a statement. You need to write it in terms of the Q to P, because they're giving you the P to Q. So you're going to write the Q to P, and if both of those guys wind up being true, rewrite it as an if. Okay? In 13 and 16, you're starting with the if. Write the P to Q and Q to P. All right? You're writing out the other two. Actually, I should have had that as P to Q first. Sorry, I meant to do it that way first. Okay. Number 19, number 35, and number 38. You have statements. I think on 19, you're trying to see. It gives you a definition. I made sure it worked. It says a perpendicular bisector of a segment is a line, segment, or array that is perpendicular to a segment at its midpoint. That's a definition. Turn that into an if. Okay. 35 and 38 also are turning them into ifs. So they're giving you statements. You have to figure out how to write them as an if. Okay? Because there's two ifs. I know, just come on. I'm not ridiculous. I'm not mean.
That's true.
It's true. And so we can do this if. Okay. So I gave you what, 7 of them? Pull up the PDF file now on your Chromebook. That way it's there for you later. If you want, the textbook is right here. If you want to take a picture of the problems, help yourself, and go from there. What's up? Check an email for me. Search an email that came from me. It's in my footer. Okay. It's in the footer of my email. It should be on there. Otherwise. Otherwise, copy that. Yes, ma'am. 35 and 38. Those are just full fragments.
All you need to know already.
Don't have it does not look all 4 of them.